Hello, welcome to the video lecture on searching. In the present video, we learn what do you mean by searching, types of searching, linear search program, and its complexity. What do you mean by searching? Searching is the process of finding a given value position in a list of values. It decides whether a search key is present in the data or not. It is the algorithmic process of finding a particular item in a collection of items. It can be done on internal data structure or on external data structure. Let us go further details of the searching. Searching algorithms are designed to check for an element or retrieve an element from a data structure where it is stored. Based on the type of the search operation, these algorithms are generally classified into two categories. One is sequential search and second is interval search. In sequential search, in this the list of array is traversed sequentially and every element is checked. Example is linear search. Interval search. These algorithms are specifically designed for searching in sorted data structures. These type of searching algorithms are much more efficient than linear search as they are repeatedly target the center of the search structure and divide the search space in half. Example is binary search. But in the present video lecture, we concentrate on linear search or sequential search. Now, try to understand the mechanism of the linear search. For that, a simple algorithm is given or approach is given, and its approach has been implemented in the diagram. A simple approach is to do linear search, that is, 1. Start from the leftmost element of array and one by one compare x with the each element of the array. If x matches with an element, return the index. If x does not match with any of elements, return -1. That means there is a list. In that list, we are searching for a given element x. Now, if we look into the diagram of linear search, a list is given with elements 10, 50, 30, 70, 80, 60, 20, 90, and 40. At the positions 0, 1, 2, 3, 4, 5, 6, 7, 8. Now, in blue color, we are seeing a number called 20 for which we are searching or finding. So, our aim is to find out 20 availability in the given list. First, we start with the first element at index 0 and we compare this 20 with 10. So, there is no match. That means at this position, there is no element. Then we go to the next position sequentially, and now second also there is no match. And gradually one by one sequentially we check. But while coming to the position index I is equal to 6, there is a match, and that means in this list the element is available, means search is a success. Therefore, now we return the index 6 as output, saying that linear search is successful and the given element is available in the given list. Suppose if 20 is not there, some other number is there. Now the search will be continued up to 7 and 8 positions also. And in this process, if at all there is no match with the numbers available and all the numbers are exhausted, then the index will be given as -1 and that will be outputted, indicating that the given element is not available in the list and linear search failed. The same can be implemented in a program. Now, let us explain the same concept in a different way. We have inputted an array with 10, 20, 80, 30, 60, 50, 110, 100, 130, 170. Now, X is given as 110. That means we have to find out whether X is available or not. So we take 110, compare with the 10, no match, but incremented to by the next value, that is 20, and there is no match, and so on. We have been checking, but at one place when the index I is equal to 6, we could find 110, that is there is a match, and therefore immediately we will skip the program and come out and print that output is 6, means search is successful and the element is at position 6. Now for example, if you want to find out x is equal to 175 in the same list, 175 is compared with the 10, 20, 80, 30, 60, 50, 110, 100, 130, 170, but at all there is no match. So all the elements have been compared and all the elements have been exhausted, and we are coming out, and in that case the uh, value index is put as -1, which indicates that search is failed and there is no element in the list. Now, whatever the algorithm or procedure that we have shown, that can be implemented in the form of a C program for linear search. Here, the program starts here like this: int main. A is the list or matrix that we have considered, A20, I, X, N are integer variables. And now, how many elements we want to choose for the list A, that is represented by N. X is the key element that we are searching for, and I is the index for moving from one element to another element of the given list or array. Now immediately, what is our aim? First we should know how many elements are required. So that is why what we are doing, we are scanning the n. So through keyboard we give the value of n. So n will decide the how many elements are existing in the given list A20. Now after that, we have to input those n elements in the array. So that is why we are taking a for loop. For I is equal to 0, I is less than n, I plus plus, scanf percentile ampersand a of I. So whenever the value of I is changing, through scanf statement, through keyboard we are giving the values, and all those values are stored against the array A. Now all the elements are available in the memory. Now what is the next step? We have to know which element we have to search. So that is why what we are doing here, scanf ampersand x. So we input the x, which is to be searched whether available in the given list or not. So again the procedure starts like this. We take the for loop. For I is equal to 0, I is less than plus plus I. Every time we are taking ai element, that is first I is equal to 0 means a0. Is a0 is equal to the inputted element x or key element x? We are checking. Suppose if there is a match, if the both are equal, means element is available. If the element is available, means search is successful, and there is no question of continuing the procedure, that we break it. After breaking, we come out of that one, and here we come to this if else block. In this case, we check whether I is less than n, and if it is true, then we print that element is found at index I. So for example, in this case, in the beginning itself it is found I is given 0. Now the question comes into our mind is that why this logic of I is less than n is taken. Here, during the searching process, there are two requirements. One is whatever the key element we have chosen, that should be matched with the element of the array. That is one thing. And in the meantime, when it is searching, whether all the elements are exhausted or not, that is also another boundary condition that we have to consider. So here what we are doing is that at this place we test for the match, but here as the every time index is increasing, with the increasing value, as we are checking with the size of the array, it decides that whether we are still inside the array or all the elements of the array are exhausted. If all the array of the elements of the array are exhausted, because we are not reaching this portion, then that means One, there is no match, number one. Number two, all the elements are exhausted, and under this condition fails. So therefore, we come to this point, and simply we say that element is not found. So thus, by implementing this program, we can implement the linear search or sequential search. Now, this is the output of the previous program. So whatever the input we have given, 21, 22, 34, 12, 66, 77, 87, 99, 09 are the elements we have given. Now enter the element to search 87. So 87 is the key element. Now what is happening? It has searched and checking it, and at position I is equal to 6, we could find the match, and we break and we come out of that one. So here, as already search is successful, an indication program finished with exit code 0, press enter to exit the console, and before that already we have seen that element found at index 6. So search is successful. Thus we can verify the linear search through a program. Now another important concept is time complexity of the program. Actually, the efficiency of any algorithm or program are tested by the concepts called complexity. One is space complexity, second is time complexity. Space complexity depends upon how much amount of memory is being occupied during the execution of the program by all the steps of the program. Time complexity means how much CPU time it is taking to execute all the steps. Based upon these two, the complexity of an algorithm is decided. The time required to search an element using a linear search algorithm depends on the size of the list of the elements. In the best case scenario, the element is present at the beginning of the list, and in the worst case, it is present at the end. The time complexity of a linear search is big O N. Thus, in the present video, we learned the following: searching, types of searching, linear search program, and its complexity. Thanks.